Today's topic will be DC biasing BJT. Yesterday I have given you one video. Did you see that? Did you watch that video? Hello? Did you watch that video?
Yes.
Okay. So what is DC biasing? DC biasing means you have to power the transistor. That is called DC biasing. Powering the transistor is called DC biasing. Now, transistor can work in two ways. One, as an amplifier. Number two, as a switch. Okay. Amplifier means it can amplify the signal. It can amplify the input and it will give you a bigger output. That means your current or your voltage will be smaller in your input and your current or output voltage will be bigger in your output. This is called amplification. Or it can work as a switch as well. What is a switch? Let me give you one hint. Okay, as a switch, how transistor works. Now see, think about this. You have a very powerful light. Let's say it needs 12 volt, 1 ampere of current, okay? You need this is a very powerful light, very bright light. You need a 12 volt, 1 ampere for turning this thing on. So you need at least a battery. Oh, this is a DC. This is a DC one. So you need battery, right? You need battery, 12 volt, 1 ampere. Battery, right? You need a battery. Understand? Without this battery, you cannot turn on this light. So how can you connect this? You can connect this like this. Right? If you connect this light will be what? On, right? But you see this thing, this light will be on forever. Forever, right? This light will be on forever because the connection is there like that. So you cannot turn this thing off unless you disconnect the battery. Okay? Connecting the battery, disconnecting the battery, this is hassle-full. So what you can do, you can use a switch. You can use a switch. That switch will, this is a switch, let's say. No. This is a switch. So what you can do, when you press it, this will be connected and the light will be on. When you unpress it, this will be what? This will be disconnected. Now pressing and unpressing, that means you need to go there, go in front of the switch and you need to press the switch physically for turning in this thing on or turning this thing off. Okay. So, but you are smart, you want to make it digital, you want to control the light using your mobile phone. So what you need a microcontroller, right? Do you know what is a microcontroller? Have you ever heard of microcontroller? Hello? Have you ever heard of microcontroller?
Yes, sir.
Okay. You need a microcontroller.
Yes, sir.
Yeah, you need a microcontroller for controlling this light using your mobile phone. So let's draw a microcontroller. This is a microcontroller, let's say. Okay. Now, you need a Bluetooth for your mobile phone connection. Let's say this is a Bluetooth. Bluetooth has 4 wires. One is red, one is black, one is blue, and one is maybe green. 4. This is a Bluetooth. This is an microcontroller, Arduino. Yes. Now, what you need actually? Think about this. Here, from your mobile phone, you give a click. That mobile phone will give a signal to its Bluetooth. This Bluetooth will take the signal to the microcontroller. This microcontroller will know, okay, I need to turn on this light, right? So it will switch on the switch. So the light will be on. Then if you want to turn it off, you give a signal. The signal will go to the Bluetooth. This signal, the Bluetooth signal will go to the microcontroller. This microcontroller will say, okay, now turn off the light. It will disconnect the switch. Now, this physical switch cannot be controlled by microcontroller. Microcontroller cannot give a push. Can it? No, it cannot give a push. Only human can give a push. So what it does, instead of these, it will use a special type of switch. Let me show you what type of switch is that. It will use a special type of switch. That's okay. Let's use this color. That switch is this one. What is this? What is this actually?
NB transistor.
Yeah, NPN transistor. Instead of that switch, it will use this. So how it will be connected? It will be connected like this. Okay. Now, so with a resistor, obviously a resistor must be there. With a resistor, let's say it is connected to a pin, any pin. So what microcontroller can do? Microcontroller can send a 5 volt or a 0 volt to its pin, right? When needed, it will send a 5 volt. When not needed, it will send a 0 volt. Okay, understand? So what it will do? So when you give the signal to turn on, let's say on, you are giving the signal to on, right? So this Bluetooth will take the signal on. This on signal will go to the microcontroller. Microcontroller will decide, okay, maybe you want to turn on the light. On signal, right? So what it will do? It will send a 5 volt. So this on signal will come here. This 5 volt signal will go to the pin. So this 5 volt will create a what? A current. This current is called IB, base current. This 5 volt will create a signal, a current, that will be IB, right? If there is an IB, what will happen? IC will flow. Understand? If IB is there, IC will flow. If IB is not there, IC will not flow. What is IC actually? IC actually is this current, right? Right? Okay. What is this current? Can anyone say? This is IE, right? Hello.
Yeah. Yes, sir.
Are you understanding?
Yes, sir.
Yes,
Okay.
sir.
So IC will come up from here. IC will flow. IC will flow. I will flow. Or you can say it IC flow, and that light will be on. So if you want to make it off, what do you do? In your smartphone, you will give a signal off. This signal will go there. This off signal will go there. Okay, the microcontroller will say, okay, you want to turn off. So it will send a 0 volt. If we send a 0 volt, there will be no IB. Okay, if there is no IB, there is no IC. No IC means no current. That means it is what? It is off. Understand?
Yes,
Understand?
Yes,
So this,
sir.
okay, this is called switch. This is called transistor as a switch. Okay, this is the transistor. This is the switch. This is the switch we were anticipated earlier. So this is the switch, and there is one more type of application of these transistor. This is one application as a switch. There is one more application of this transistor, that is as an amplifier. Okay, let's see that first. So here you have a transistor. Okay, now here obviously something like this. Now, in this circuit, if you connect an AC input here, and if you take the output from here, you will see your input got bigger. That means that this is your output, this is your input. Understand? This is called amplification. This is called amplification, amplifier. Your signal will be amplified. Amplified. Understand? But what is this circuit? This circuit is the amplifier based on NPN transistor or PNP transistor. But what is this circuit? The additional circuit. That is the transistor that we know already. But what is this circuit? Additional circuit. This circuit is the biasing circuit. Biasing circuit. What is biasing circuit? Biasing circuit are the circuit that provides the power. Let me give you one hint. Let's say this is a speaker. Okay, this is a speaker from where you can hear the sound. There is a wire and you have a microphone. Okay, you have a microphone. You are speaking here. What will happen from here? A big sound will come, right?
Yes, sir.
Big sound will come and your voice will be louder. If you speak in microphone, if that is connected to the speaker, what will happen? You will hear a lot of sound, right? But there is a problem. Okay, air. Which one is input? Which one is output?
Microphone is input.
Microphone is input.
Yeah, that means your voice is the input, right? That means your voice become an electrical signal. So this is the input. Which one is output?
Speaker.
No, not speaker. Speaker is the output device, but output is the voice, right? The sound. So this is the output. Got my point? So maybe your input is like this. Your output will be like this. Okay, big. Okay, maybe your input is like this and your output will be like this. Understand? So your output must be bigger, otherwise what is the point of using an amplifier? So your output is bigger, but how? Okay, is there anything needed? Is there anything more needed for this? Only a speaker and a microphone? Only a speaker and a microphone, or you need anything else?
We need anything else, bro.
What?
Sir.
Sir, battery.
Yeah, the battery or the power, right? Or the current, electricity. You need battery or electricity, understand? So that is what? That is input or output? Battery is input or output?
Sir, output.
Output, sir.
No.
Input.
No.
Input.
No. Input is this one. Output is this one. What is that? Battery is input or output? Nothing. Battery is biasing. Battery is power. Battery is what? Power or biasing. You can call biasing or bias. So battery is actually your power or biasing. Okay, understand? Remember, every circuit needs some power. That is not its input, not its output. It is required for running the machine. It is required for turn on or keep the machine turned on. Okay. So today we will be seeing DC biasing. There are 4 techniques of DC biasing. Oh, remember this. This is already, we have already known. VBE is equal to 0.7. IE is equal to IC plus IB. Okay. Let me show you this equation. We already know IE is equal to IC plus IB. So here, in case of IC, can we write these? Of course, we can write this, right? Beta IB plus IB. So from there, can we take IB common? So this is the relationship between IB and IE. This is the relationship between IB and IC. Okay, the relationship. This is the relationship between IE and IC. Almost equal. So we can actually use those, and we will be using those in our DC biasing. What is that? DC biasing problems. Here, this is called operating point. So this characteristics curve is the whole characteristics curve. That means whole means for every possible voltages. But remember, you will not be using every possible voltages. You will be using only one possible voltage or one voltage, right? Here, this graph is drawn for every possible voltage, every possible current. But you are not going to use every possible voltage. You are going to use only one voltage, one current. Okay? So that according to your voltage and according to your current, you might have a point. Okay? You might have a point. That will be your operating point. Let's say here, your voltage is 7 volt or 8 volt, and your current is 10, and your IB is 30. So your operating point is this one. You might have your operating point here. You might have your operating point here. Understand? It depends upon your wish. That is called operating point. Okay, sometimes it is called quiescent point. Quiescent. Can you see? Sometimes it is called quiescent point. Quiescent means quite, still, inactive. Sometimes it's called. This is called Q point. Abbreviated as Q point. Q point means your operating point. Okay? Now, here, you can see fixed bias configuration. Remember, you have 4 different types of configuration technique, and we will be learning all 4. You have 4 different biasing technique, okay? And we will be learning 4 of them. Okay, let me show you a slide. I have already given you this slide, but you haven't understand yet. Wait a minute, I'm going to give you the slides. Teaching material. Okay. Now, we have 4 different techniques of configuration of the DC biasing. Number 1, fixed bias. Number 2, emitter bias. Number 3, voltage divider bias. Number 4, biasing with voltage feedback. Okay, but most common one is the fixed bias, then emitter bias, then voltage feedback, or what is that? Voltage divider bias. Okay, those are the most common one. Okay, let's see here. See this. This is the voltage feedback. No, this is the fixed bias configuration. Why it is called fixed bias? Because there is no resistor at the bottom. At the bottom of the emitter, there is no resistor. Here, what you have? You have a resistor here that is called RB. You have a resistor here that is called RC. And you have only one voltage source. Okay, you can use only one voltage source. Or if you want, you can use two. You can use two different. Okay, you can use two different voltage source if you wish. But since we are habituated of using only one battery, so that's why we are using only one battery. Okay, but remember, since we have only one battery, so we have to control the current. We have to control the IB and IC. Remember, I told you IB is much smaller than IC. So you have to give your battery resistance here much bigger than RC. Otherwise, IB will not be smaller, IC will not be bigger. So that's why these are normally 100 kilo ohm to, let's say, 800 kilo ohm. This is not fixed. These can be changed, no problem. So these are normally in that range. And this one, sometimes it is 1 kilo ohm, maybe 0.5 kilo ohm, maybe 2 kilo ohm, something like that. Are you understanding the range, right? So that one is much bigger. This one is much smaller. Okay, so here this part is the biasing part. That means the power part. Okay, here with that you have a capacitor, then you have your AC input signal. After that you have a capacitor, then you have AC output signal. So why the capacitors are used? Capacitors are used so that the AC cannot mix with DC. This DC cannot come and go and mix with the AC. It cannot, because there is a capacitor. These capacitors are called DC blocking capacitor. These capacitors are called DC blocking capacitor. So no current can come and go in this way. No DC current. No DC current will come and go this way. Only the AC will go that way. That's why they are called DC blocking capacitor. Why they block DC? Because the reactance of capacitance is 1 divided by 2 pi FC. Since the frequency of DC is 0, so if you put 0 here, it becomes infinite. So the resistance becomes infinite for capacitance. So that's why no DC can go. Only the AC can go. Okay, this is why they are called DC blocking capacitor. So if they block DC, what will happen? This will happen. Something like this. A circuit like this. Now you have to, at first what you have to do, because we are not dealing with input, we are not dealing with output, we are only dealing with biasing. Okay, so what you have to do, you have to remove the AC and AC from the circuit. Then what you have to do, you have to analyze the circuit. How to analyze it? There are some analysis technique. Let me show you something. I have a slide for that. This is the slide from the video. Fixed bias configuration. So this is the fixed bias configuration. What you have to do at first, you have to get rid of those DC blocking capacitor. Then you have to find out the IB, you have to find out the IC, and you have to find out the VCE. Why? Because remember the characteristics curve we have drawn in our previous class, that is yesterday. That curve was according to VCE, IB, and IC, right? Three of them were there. That's why you have to find all three. So you can see your characteristics curves are according to your IB, IC, and VCE. That's why these three are the most important things for us. We will be finding out all three. So how can we find out these? We have to apply a KVL in this side, KVL. In the input side, we have to apply a KVL. Applying KVL in RB side, VCC minus IB into RB minus VBE. How? See, here, this is the source, so VCC minus IB into RB, because the current here is IB and the resistance here is RB. So IB into RB minus, you have another drop where here, oh no, you have another drop here, that is VBE, because this is a PN junction, right? This is P, this is N. This is an NPN transistor, NPN. So this junction is PN. So like a diode. So here there will be a voltage drop, VBE. Normally it is 0.7, because if it is made of silicon, normally it is 0.7. It is made of silicon. That's why. So here you have VCC, here you have IBRB, here you have VBE. Next you have 0. That's why VCC minus IBRB minus VBE is equal to 0. This is the applying the KVL in RB side. So from there, VBE is 0.7. VCC is equal to VCC minus VBE. Take the IBRB on that side, because VCC is known, VBE is known. Take the IBRB on that side. RB is also known. Take the RB at the bottom. So your IB is equal to VCC minus VBE divided by RB, right? That is your formula for IB. Now, what is your IC? IC is equal to beta IB. We know it. What is IE? IE is equal to IC plus IB. We know it. Okay, for VCE, you have to apply a KVL in this side. Okay, so applying KVL in the RC side, what do you have? VCC minus ICRC, because this drop is IC into RC, minus VCE. VCE is this one, this drop, the whole drop equal to 0, because you do not have anything here. So after this drop, you have ground. That's why 0. So here the unknown thing is VCE. Take the VCE on the other side. So VCC minus IC into RC equal to VCE. So let's solve a math problem on fixed bias configuration. Okay. So here, this is the problem. Determine the following for fixed bias configuration in the figure. So here you have to find out IB, IC. Why Q? Q is the quiescent point. Remember the Q point, the operating point, is nothing actually. So that means for this setup, for these 12, these all setup, find this. So IB, IC, then you have to find out VCE, then you have to find out VB, VC, and VBC. Let's find out. So at first, what you have to do, you have to get rid of those DC blocking capacitor. Then apply a KVL in the RB side. What do you have? VCC minus VCC minus IBRB minus VBE. Where are those? VCC at first this one, then IBRB here. Next drop IB into RB. Next drop VBE. Next equal to 0. Okay. So unknown thing is IBRB. Take that on the other side. So VCC minus VBE is equal to IBRB. So IB is equal to VCC divided minus VBE divided by RB. So take the RB on that side. So VCC is equal to 12 volt. VBE is 0.7 volt. RB is equal to 240 kilo ohm. So your value is equal to 0.04708 milliampere. If you multiply it with 1000, your value is 47.08 microampere. Now IC. IC is equal to beta IB. Beta, the value of beta is 50. It was given in the question. It was given in the question. Okay. Beta is equal to 50. IB is equal to 0.04708 milliampere. Okay, if the beta is not given, it is 100. So 50 into 0.04708. Why I am not using these? Why I am using this? Because IB will be in microampere, IC will be in milliampere. Since it is in milliampere, that's why I am going to use a milliampere range, and so that I do not have to convert it again. Okay. So IB will be in microampere, IC will be in milliampere. That's it. Now from there you got 2.354 milliampere. If you, since the question didn't ask you to do this, but yet you can do it. IC plus IB. IC is equal to 2.354 milliampere. IB is equal to this one, not this one. 0.04708 milliampere. If you add this, you got 2.401 milliampere. That is IE. That is not necessary for your math. Now for VCE, apply a KVL in this side. Okay. So what you have VCC, then you have minus ICRC, then you have VCE, then you have 0. This is the KVL. So unknown thing is VCE, take that on the other side. So VCE is equal to VCC minus IC into RC is equal to 12 volt minus 2.354 milliampere into 2.2 kilo. So milli and kilo, they become volt. So volt minus volt, they become volt. 6.8212 volt. Here you can see I have used Q. You can wish, as you wish, you can use it, or you cannot. You do not want. You can skip it, no problem. Okay. So this is the question number A. This is the question number B. The answer to the question number B actually. Next, what they ask for? They ask for VB and VC, then VBC. Okay, now VB. What is VB? VB is the voltage between these 2 points, right? Why? Because if you want to measure the voltage of this point, you need a multimeter, and the plus pin, that means the red pin, should go here, and the minus pin should go to the ground. Where is the ground? Here is the ground, right? So actually what you are measuring? You are actually measuring the voltage between these 2 points. So this is a VB. So can we call this is VBE? Can we call this is VBE? So it is 0.7. Now the VC. Oh, in other way, you can do this. VBE is equal to VB minus VE. Now VBE is 0.7. VE is 0. Why 0? Because it is connected to the ground. So according to that, you can call VB minus 0 is equal to VB. So VBE is equal to VB. Now you have to find out the VC. Again, VC is the voltage between these 2 points. This is the ground. Again, this is also VCE. Can you see that? This is VCE. So we can call VC is equal to VCE. That was 6.821, right? That you have already found out. Now the VBC. VBC. VBC is equal to VB minus VC. VB is 0.7. VC is 6.8212. So the value will be minus 6.1212 volt. So that is the part C. That is the part D. So that is your math. Have you understood, everyone?
Yes, sir.
It is easy?
Sir.
Very easy, right?
Yes, sir.
Okay, let me give you one exercise. Let's you do it. Yeah. Question number 1, you do it. Take 5 minutes of time and do it. Okay? Find all of this. Understand?
Yes,
Hello.
sir.
Okay. Take 5 minutes and do it. I'm going to pause the recording for now. So what is your answer? Hello. Should I solve it for others so that you can check?
Okay, IB is equal to.
Okay, yeah, I'm going to do it. You check it. Okay. So
Okay, sir.
at first we are going to use a KVL in this side. That means in this side, right? So
Yes,
what do we
sir.
need? At first 16 minus, here let's call it IB.
Yes.
IB into 510,
Yes.
right? Minus VBE, that means 0.7. Okay, let's write 0.7 directly. Okay,
Yes, sir.
0.7 equal to what? Equal to 0. So only unknown thing is IB. Okay,
Yes.
so IB will be 16 minus 0.7 divided by 510.
Yes.
So your IB will be how much? Okay, let's calculate.
0.03 milliampere.
Minus 0.7 divided by 510. So 0.03.
Yes, 30 microampere.
Yeah, 0.03 milliampere. Why it is milli? Because this thing, okay, let me write it here. Because this thing is in volt. This
Volt
thing is in
kilo
kilo ohm.
Yes.
That's why it is in milliampere. Okay. Now we can call it 30
Microampere.
ampere. Very good. You got it. Now I am going to use a what? A KVL on the other side. That means in this side.
Yes.
But before that, let's write IC. Because you have to find out the IC as well, right?
Yes.
Okay, you can call it IBQ. Remember, you can call it IBQ. What is your ICQ?
Beta times IBQ.
Yeah, beta times IBQ. So beta is 120. So you can write 120 into 0.03.
Yes, yes.
So how much? 120 into 0.03.
3.6 milliampere.
Exactly, 3.6 milliamp. So 3.6 milliamp. Okay.
Yes, sir.
Now come VEQ, VCEQ. Now
Yes.
VCEQ, we have to apply the KVL again. 16 minus IC. No, IC we know already, right?
Yes, yes.
IC we already know. That is 3.6
Yes.
milli into 1.8 minus VCE. Let's say VCEQ is equal to 0. Okay.
Yes, sir.
So from here, what we can do?
PC.
VCE Q is equal to these 16 minus 3.6 into 1.8. 16 minus 3.6 into 1.8. So 9.52.
Yes, sir.
Okay, what is your role, by the way?
47.
47. Okay, 9.52 volt, right?
Yes, sir.
So now comes the VC. What is VC? For VC, remember you need a multimeter, right?
Yes.
So multimeter pin, this is the multimeter. So red pin will go where? Here. And the black pin will go where?
Ground.
to the ground. That means here. That means actually what you are measuring now.
VCEQ.
VCEQ.
VCEQ, yes.
Exactly. So we can call it VCEQ.
EQ.
That means
9.52.
9.52 volt. Now VB. Again, same thing. You will be measuring VBE.
Yes.
So how much?
0.7.
0.7. What is VE? It is pretty simple, right? You do not need any multimeter. What is this?
V
VE. The voltage of this point. How much? How much is this? Roll number 54. Now 47.
Yes, sir.
What is this?
This VCEQ.
No. VE. VE. This is VE, right? VE is connected where?
Ground.
Ground. So how much?
0.7.
Oh no. See, if you need a multimeter.
0.2 minus 9.52, sir.
No. See, this is the multimeter, right? So
Yes.
red pin will go here. Where will the black pin go?
Ground.
In the ground. Where is the ground? This is the ground, right?
Yes.
So actually you are trying to measure a point that is also already ground.
Yes.
So what is the voltage? What is the voltage of the ground?
0.
Exactly, 0, right? So
Yes.
you are
Yes.
actually measuring the voltage of the ground because we do not have any resistor or anything else, just pure ground. That's why your voltage is 0. Next time, that means in the next math, you will see there is no ground here. You have a resistor. That time you will have a VE. Okay?
Yes.
This is 0 volt. Understand?
Yes, sir.
Yes,
Okay, very good. So this was the math. I believe all of you understand this. This is a pretty simple one. Next, we have the lecture number 2. Okay. I do not need it. We have a lecture number 2. This is lecture number 1. So where is the lecture number 2? Here's the lecture number 2. See, I'm going to give you the lecture right now. What do you do? You see the animation. Here are some animations there already. Okay.
Only resistor is
The only resistor is connected. That's why it is called emitter bias.
yes.
What is called?
Emitter bias.
Emitter bias. Emitter bias means there is a resistor in the emitter. Previously it was called fixed bias. Now it is called emitter bias. Now because emitter has a resistor.
Yes.
Okay. So the same thing, same procedure. All 4 maths, that means all 4 types have the same procedure. Do not memorize the formula. If you memorize the formula, you will forget. Okay. You will be confused.
Okay.
What you do? You memorize the method, how to do it, how to write the formulas. Okay, got my point?
Yes.
People might say, okay, memorize the formula. No, do not memorize the formula. Never memorize the formula. If there is another way, do not memorize the formula. Okay?
Yes.
Okay. So again, you see the animation and you will understand. Yet I will make you understand in the next class. And but I believe all of you can solve it without any help from me. But if you see the animation, all the animations are there. I step by step I have arranged all of those for you. You can see those. Okay.
Okay, sir.
I'm going to give you right now in the where can anyone see here? Can you knock me in the Facebook because I am in the computer desktop. I do not have WhatsApp in the desktop. Can you knock me in the Facebook?
Yes, sir.
Knock me in the Facebook. I will give it to you, and so that you can give it to the in the WhatsApp group. Okay, is that okay? Hello.
Yes, sir.
Is that okay?
Yes. Yes.
Okay. Knock me in the Facebook right now.
I know with you, sir.
Okay. So wait a minute.